Hello and welcome to a new webinar in our Tech Tuesday series, even though today is Thursday. Our topic is Safe Speed Evaluation, the future of machine safety. So, why is functional safety so important? Well, it protects users and machines against a wide range of hazards. And it's also an important factor to reduce costs and increasing efficiency. Today I would like to welcome Thomas Peters, Head of Application Sales, and Bernd Tünnermann, Functional Safety Engineer. Both are here from KEB. So, they will present the topic to us with a focus on drive controllers. So now I would like to hand over to Thomas.
Hello, ladies and gentlemen. I also would like to welcome you here on our Tech Tuesday special Safe Speed Evaluation with KEB drive controllers. First of all, I want to introduce you why safe speed evaluation is so important to your machine. Like you all know, according to Article 5 of the Machine Directive, every machine manufacturer has to fulfill the rules for health and safety requirements to this directive. And also, it's very important to integrate all the safety in an established way. And one of these established ways for sure is to use the internal safety functionalities, for example, of the KEB drive controllers. Depending on your application, you have different modules in the machine regarding inverter, motors, additional input or output filters or chokes, and all these are different hardware positions according also to the IEC 61800.2. And if you want to fulfill the rules of safety inside of your machine, you need actually special hardware, for example, for speed or standstill monitoring. Also, this hardware means you have to wire some hardware. Sometimes you have to parameterize this special hardware by software and so on. If you want to bring down your costs, from our point of view, it's very sensible to integrate your components directly into the inverter or in the motor. This is, for example, a safety module that can be inside of an inverter, and also typically it's to use encoder for speed and standstill to detect the speed or standstill monitoring directly in the machine. In a typical application you have an encoder just for the speed regulation or position regulation, and this means on the motor side there are mainly no changes to do to fulfill these rules, and just in the inverter side you need an inverter with a special safety certificate. Regarding the safety also, one of the big problems is the wiring in the application. Therefore, you can also use different solutions. For sure, you can directly mount everything in hardware, also the wiring, but this also means costs. In modern applications, you can also use the field bus, which is typically directly in your machine, so that you can use, for example, the EtherCAT bus plus the FSOE, the safety over EtherCAT field bus, or also in your Profinet applications, for example, the ProfiSafe field bus, to fulfill the safety rules and also to control the machine directly by field bus. The only thing you have to do is to add a safety PLC inside of your application with a module that can handle the safe field bus by itself. And this means that you can reduce the costs of the wiring because the field bus is still in your application. If we have a look on the different technologies of speed evaluation, we have mainly three different types of evaluation, which is very typically, for example, the analog speed monitoring, which means you have, for example, a sinus-cosinus encoder or a resolver in your application, which is typically known in the market. Also, if you have other encoders like digital ones, you can also use digital speed monitoring like hyperphase safety or others, which means you have to the analog information additional safety information, and you can also use this connection by safe field bus connection to get additional information. And the third one, which we want to present you today, is the encoderless speed monitoring, which means that you can use speed monitoring together with a KEB drive controller, but there's no need of any kind of resolver or encoder in your application anymore. And this means if the application does not need an encoder, there's also no need to use an encoder just to have safe speed evaluation. This is one of the big benefits here from KEB that we want to show you today. Just to bring it here in front of you, I just added the typical main facts for safe speed evaluation with encoder. Like I said before, in many applications we still have an encoder, so it's just a question of certifying this application together with the encoder. Also, one of the big benefits is if you use an encoder, for sure you can also start from standstill to the maximum. Here are some limits for encoderless safety. And there's typically no or just a little effort in certification if you have already an encoder in your application. Typically, the manufacturers of the motors can give you, for example, a certificate for the motor encoder combination, so that there is very limited effort in your in a startup of the machine or of the application to certify it. Also, if you want to have position-related safety functionalities, you always have to use an encoder, because otherwise there is no clear information about the actual position, and so there is no other possibility up to now to handle this. Without an encoder, like I also said before, there's no need to use an encoder, which means less cost in motor-encoder combination. For sure, you also need no encoder interface in your drive controller, which also means that you can reduce the costs of the, of the inverter. Also, if you have all this information directly in the inverter, the response times to figure out if there is a safety-related fault are much faster than the feedback from the encoder due to the less roundup time. Also, it's possible to evaluate high-speed applications with applications using safe speed but without an encoder. And all this can also be certified up to ZEAL 2, which is a performance level D. For sure, there are a lot of pros, but there are also two cons. Like I told you on the first slide, you cannot directly start at standstill, which means safe operating stop is not possible together with encoderless safety. And also encoderless safety is not possible in operations where you have regenerative operations. So in this field, the possibility to calculate the speed are not given internally, and so these applications are also not possible. So if we have a look on the safety functionalities here, for sure the first one we are always talking about is the safe torque off STO functionalities, which is more or less the release function for the inverter to give torque to the motor shaft or not. And also combined with this, the SS1, which means safe stop 1, which is more or less a time monitoring during a standstill operation. The inverter is lowering from the actual speed to 0, and after a time the STO will be given. And this is if you have a safety fault. The SS1 functionality is, besides the STO, the only safety function you can parameterize if there is a safety fault as a reaction of it. Otherwise, it's always STO. If we have a look on the safety-related safety functions, you can also see always on is the safe maximum speed. You can, for example, monitor maximum machine speed that you don't have to switch on or off. You always want to lower or limit the application to, let's say, 220 RPM. So this is a functionality where you can give the 220 RPM directly to your application and there is no need to switch it on. Also, the other safety functions like SLS, safe limited speed, safe speed monitoring, or safely limited acceleration are also directly in the inverter and can be parameterized by our tools. So speed monitoring can be used during the machine process, not at standstill. If you want to start up an inverter, you can do this directly with the very well-known Combi with 6 software from KEB, which is the software for the parameterization of the standard inverters and can also directly be used in this free version for the safety-related functionalities. And to give you an introduction of what is possible with this, we have here Bernd today to show us on our model some functionalities of the wide range of safe speed evaluation without an encoder. So welcome, Bernd, here.
Yeah, welcome. My name is Bernd Tünnermann and I'm in the training department responsible for trainings in safety. Yeah, I will show you how the function of the drive is by our demonstrator here. This demonstrator consists of a CombiVert S6 Pro with a safety module 5. We have a synchronous motor without an encoder, and always we have 2 light bars which switches directly safety functions. And we have a display here to manage some movement. So when we start, we can set a speed. So start. The inverter runs, and with the first light bar we have directly connected to the input of the drive, so we have safely limited speed, and the second light bar we have safe torque off, the STO, so that the motor stands still. Now we need a little help, so please activate the first light bar, and you see here that we are in status safely limited speed. 150 RPM is limited, and when you put your hand a little deeper, then you go to STO and the motor stands still. So when you put your hand out, you see we are coming from disabling STO to disabling SLS, and the motor starts again.
So like you see, all these functions are implemented with a motor without encoder feedback. So we use our internal motor modules to run the motor very exactly, and we can also very exactly identify that we are on the right speed and that we do not rise the maximum limits of the parameterized safety functionalities. But regarding to all these speed functions you saw before, there are also applications where you have the need of combining functionalities. Like at KEB, we have the possibility to combine up to 8 different safety sets directly in the drive controller. But besides that, there is also the need for you, for example, to directly control a door to get in your application, like on woodworking machineries or something else. So we from KEB side decided to implement a functionality that is not directly coming from these safety-related functions. We called this new KEB function Safe Door Lock Control for different applications in use. And this is also something where we have like the shown SS1, safe speed acceleration functionalities and so on combined to one new KEB safety function where you can directly control your door with. And here as a scheme you see what happens. We have a typical speed And if you activate this functionality, you will lower down your speed in a controlled way without encoder to 0. And the KEB drive can detect this, will also detect the maximum and minimum deceleration speed that you are in line. And if you are at 0 Hertz, you can give a safe output to directly control, for example, your door and release it to open your application only if the machine has stopped in a safe way. And this is also something Bernd will show us now here at the demonstrator.
Yeah, okay. So at our demonstrator box, we have a door here, which is on top here, and now it's closed. And for example, we start the machine again. So, and now when we want to open the door, we can put down the speed to 0, stand still, and then we have here an activator for the SDLC function. So that means we go in function SDLC, and then the output is activated and opens the door release switch. So we can open it here. And now the drive is in status also in STO, so it cannot start. And when we close the door, then we lock again, and then we can start again. So, and we rise up the speed again. So the other possibility is that we directly engage the door release. So the drive is decelerating and opens the door release switch, and so that we can open the door without any engaging of a separate controller. And we can start again, and the machine is running again.
So you see, with a combination of safe and unsafe functionalities like starting and stopping in an unsafe way and controlling this in a safe way, you can combine your needs of the application with KEB drive controller, reduce the wiring, reduce the installation costs, also the parameterization of your application, and get new possibilities in your machine. And this is what we wanted to show you today here from KEB of the Tech Tuesday with our experience now in more than 20 years of safe evaluation in the VFDs, in the drive controller. I want to thank you for your time today, and yeah, I'm really happy to see you next time here in the KEB studio.